Nitrogen is a chemical element with symbol N and atomic number 7. It was first discovered and isolated by Scottish physician Daniel Rutherford in 1772. Although Carl Wilhelm Scheele and Henry Cavendish had independently done so at about the same time, Rutherford is generally accorded the credit because his work was published first. The name nitrogen was suggested by Jean-Antoine Claude Chaptal in 1790. When it was found that nitrogen was present in nitric acid and nitrates, this name derives from the Greek roots nu tau rho omicron nu, niter, and gamma epsilon nu to form. Antoine Lavoisier suggested instead the name azote. From the Greek alpha zeta omega tau iota kappa omicron sigma, no life. As it is an asphyxiant gas, his name is instead used in many languages, such as French, Russian, and Turkish, and appears in the English names of some nitrogen compounds such as hydrazine, azides and azo compounds. Nitrogen is the lightest member of group 15 of the periodic table, often called the pnictogens. The name comes from the Greek pi nu iota gamma epsilon iota nu, to choke, directly referencing nitrogen's asphyxiating properties. It is a common element in the universe, estimated at about 7th in total abundance in the Milky Way and the Solar System. At standard temperature and pressure, two atoms of the element bind to form dinitrogen, a colorless and odorless diatomic gas with the formula N2. Dinitrogen forms about 78% of Earth's atmosphere, making it the most abundant uncombined element. Nitrogen occurs in all organisms, primarily in amino acids, and thus proteins, in the nucleic acids, DNA and RNA, and in the energy transfer molecule adenosine triphosphate. The human body contains about 3% nitrogen by mass, the fourth most abundant element in the body after oxygen, carbon, and hydrogen. The nitrogen cycle describes movement of the element from the air, into the biosphere and organic compounds, then back into the atmosphere. Many industrially important compounds, such as ammonia, nitric acid, organic nitrates, propellants and explosives, and cyanides, contain nitrogen. The extremely strong triple bond in elemental nitrogen, N, the second strongest bond in any diatomic molecule, dominates nitrogen chemistry. This causes difficulty for both organisms and industry in converting N2 into useful compounds, but at the same time means that burning, exploding, or decomposing nitrogen compounds to form nitrogen gas releases large amounts of often useful energy. Synthetically produced ammonia and nitrates are key industrial fertilizers, and fertilizer nitrates are key pollutants in the eutrophication of water systems. Apart from its use in fertilizers and energy stores, nitrogen is a constituent of organic compounds as diverse as Kevlar used in high-strength fabric and cyanoacrylate used in superglue. Nitrogen is a constituent of every major pharmacological drug class, including antibiotics. Many drugs are mimics or prodrugs of natural nitrogen-containing signal molecules. For example, the organic nitrates nitroglycerin and nitroprunicide control blood pressure by metabolizing into nitric oxide. Many notable nitrogen-containing drugs, such as the natural caffeine and morphine or the synthetic amphetamines, act on receptors of animal neurotransmitters.